Hi everyone, I'm Karthik, a PhD student at the University of Toronto. Today I'm presenting work done during my internship with Autodesk Research titled Tesseract, Querying Spatial Design Recordings by Manipulating Worlds in Miniature. Designers often review their work or the work of others during the design process. Previously, researchers have proposed interfaces to help designers review 2D design recordings for various purposes, including learning new workflows and understanding design rationale. Recent VR collaborative design tools have made it possible to create and use spatial design recordings containing multimodal data about objects, people, and their interactions. Objects can include 3D models, textures, animations, and entire scenes. As designers compose a new design, they manipulate objects and their properties, creating versions of the design at each moment, which can be recorded and later retrieved through querying. Spatial design recordings also record people as they engage in the design process by capturing their activities. Activities are recorded across frames, including how people move around the virtual environment, what they're looking at, and verbal dialogue with themselves or others. Spatial design recordings are typically created in feature-rich applications that include tools for manipulating objects, such as when a 3D model is moved, so these interactions can also be logged and retrieved. Despite their potential to serve as design aids, searching these recordings presents many challenges. First, spatial design recordings contain multimodal data about objects, people, and interactions. Second, they occur over multiple frames and are recorded over multiple sessions. For instance, when a designer is making an interior layout for a client, the process to finalize the design takes multiple sessions, where the design is reviewed and iterated upon. Existing search techniques designed for searching 3D models and static 3D scenes do not support searching across multiple frames. On the other hand, existing timeline navigation techniques for spatial recordings can support scrubbing or jumping across multiple frames, but do not support searching multimodal data. Further, users are restricted to browsing a single recording at a time. Hence, the challenge of querying spatial design recordings lies in their lack of support for users to express their search intent to retrieve moments that consist of multimodal data across multiple frames in multiple sessions of recordings. We present Tesseract, a worlds and miniature-based system to support searching spatial design recordings for interesting moments of past design activities. Tesseract is built on top of the Search Cube interface, which lets users express their search intent. Similar to a search bar in a conventional search engine, the Search Cube interface supports users in defining the 3D content that make up relevant moments that they wish to find in past recordings. How to define the 3D content depends on the type of data one wishes to incorporate in their search. In this work, we explore spatial design recordings from the lens of interior design. Hence, to search spatial design recordings, we created 4 querying tools: object search, proximity search, viewpoint search, and voice search. Object search allows users to add and manipulate objects into the search cube to define relative layouts that might exist in previous recordings. Each object becomes part of the query through its presence in the search cube. By selecting an object, users can include them in the search, prioritize them, or exclude them. When multiple objects are inside the search cube, Tesseract automatically detects object-object relationships, such as when 2 objects are next to each other. Proximity search lets users define the location of recorded people in proximity to specific objects they may be interacting with or visually examining, such as when designing for accessibility in support spaces. A resizable selection disk represents the area around a recorded person in proximity to nearby objects. Users can manipulate the disk to define the recorded person's location. They can also resize the disk to include more or fewer objects next to the person. Proximity search can also be used to specify an absolute location within a room that the recorded person was in. To access this, the user can replace the generic search cube with a specific 3D layout that they might have copied from their current environment. Viewpoint search supports querying by letting users define their own recorded viewpoints, or areas that a recorded person may have been looking at, either while stationary or moving around. A recorded viewpoint acts as a proxy for a recorded person, and the viewpoint's position and orientation can be manipulated to filter which objects are visible. To define a sequence of viewpoints that a recorded person demonstrated, frames in time can be used. When multiple persons or recorded people are present, users can add more recorded viewpoints representing them. Each recorded viewpoint has their own trajectory defined using individual frames. Lastly, voice search enables users to find events logged when people interact with the design software and objects in the virtual environment, such as when adding or deleting 3D models. It also supports finding conversations or think aloud dialogue by designers. We evaluated Tesseract in a 10-participant user study. We provided target clips for participants to find to ensure that they had the same search goal so that we could observe the variations in how they use the querying tools. 7 target clips were chosen based on scenarios involving understanding design rationale, reflecting on designs, and learning new workflows. Participants then used the Search Cube interface and the associated querying tools to look for the target clip. Lastly, they used the results of their search to find the target clip. In the study, we collected data about participants' usage of Tesseract and the associated querying techniques. We also collected qualitative feedback, such as reflections on the querying tools and the Search Cube interface through questionnaires and an interview. For each task, we aggregated participants' resulting search cubes to better understand their search patterns. For instance, in the object search task, the left 2, we counted how many objects and the types of objects participants included in their query. This helped us observe interesting usage patterns participants exhibited. First, we noted that most participants included objects that were the focus of the recorded designers from the target clip. In the case of the first object search task, this included the refrigerator that the designer was adding during the target clip. More interestingly, participants also included peripheral objects not mentioned or interacted with. For instance, the island counter was never interacted with in the clip, but participants still included it. Every single one of them did. This suggests that these objects may serve as spatial anchors that help describe the moment to be found. If in-focus objects represent the activity, then peripheral objects represent the context. We also found that most participants were coarse when trying to replicate the layouts from the target clips. Only one participant replicated the exact layout in the target clip. Most opted to include only partial layouts with some of the objects. However, most participants were precise in their placement of objects with respect to each other, including their relationships. This trend was visible also when placing the selection disk in the proximity search task and recorded viewpoints in the viewpoint search tasks. Lastly, we observed that most participants refine their queries after seeing the search results, which is akin to how people use conventional search engines today, where text queries are rephrased when the desired result is not found. Hence, we found that our proposed querying tools offer different ways for users to express their search intent and to iteratively refine them. Participants also found the Search Cube interface and querying tools easy to learn, use, and efficient. Together, Tesseract provides a toolbox for users to express their search intent when searching for past design activities. To conclude, through Tesseract, we present the idea of stage-to-query using a miniature-based VR interface across space and time. We introduced 4 new querying tools, and we showed that using these querying tools, participants were able to express their search intent and retrieve past design activities from spatial design recordings. Thank you.